fitting bell curves to data distributions using visualization. This was a crowdsourced study in which we attempted to answer one central question. Do people have the visual intuitions to link realistic data samples with the idealized curves upon which many inferential statistics depend? We presented the respondents with this, a normal curve and a distribution. They could then use the controls on the screen to center the curve, find the mean, and then adjust its spread, finding the standard deviation. Once they were happy with what they'd seen, once they were happy that they had found a good fit, there was no timer on this, they could hit the submit button to move on to the next. We presented users or respondents with more than just the standard bar histogram. We presented 4 different visualization types: the bar histogram, a Wilkinson dot plot histogram, strip plots, and box plots from Tukey. Now the box plots, by the way, don't have the outliers. It's just the box and whiskers. Our intention was to produce a variety of visualization types that varied principally in their degree of abstraction, where the box plot is, of course, the most abstract. It consists of only a few measures of spread, measures of central tendency and distribution. Whereas the strip plot is the least abstract. It actually shows all the detail, and the 2 histograms are in between. Now, as data viz people, and all 3 of the co-authors on this study, we have a bias towards believing that more detail is better, that visualizations that are less abstract and more detailed will be superior. But what did we find? So in addition to presenting the 4 visualization types and the apparatus that I've already demonstrated, we also did training and attention trials. Participants were asked to match their controlled curve in the red line with a correctly fitted curve, that is to say the blue dotted line. The example here shows a strip plot, but we did include training trials for each of the different 4 types. We would present all of the box plots together. We would present all of the histograms together. But within each type, or within each section, the order of the trials was randomized. But of course, they always saw the training trial first. In all, we varied other things in addition to visualization type. We also varied the size of the sample. We had samples of either 50 or 200 members. The essential intuition here is, as a sample becomes larger, its normality becomes smoother. It appears less spiky, whereas smaller samples tend to have a lot more visual variability. Spread. We adjusted the standard deviation so that the coefficients of variation were either 0.2 or 0.4. I already mentioned that we did 4 different visualization types, and we had 48 trials per participant. What this means is altogether we had 48 trials per participant. Now, when I say 48 trials, we actually used the same dozen data sets for all participants. All participants saw the same data sets, so we can actually make comparisons across. We can actually compare how they did with the different visualization types. So they would see each of these dozen distributions, but instead of seeing them all as, they would see them all as bar plots, but they would also see them all as dot plots, box plots, etc. Who were our participants? We had 117 participants in all. It began with 146, but 19 failed the attention trials, and so we removed them. And 10 seemed to misunderstand the directions. They hadn't taken advantage of the ability to do a fit of the spread, only moving the curve side to side. And so we eliminated those as well. They tended to skew very young, very highly educated compared to the population as a whole, which is not surprising given a crowdsourced study, which does require people to have both a computer and the leisure time to use it. And critically, they report having either very little experience with statistics or almost none. Nothing more than no advanced training, nothing more than perhaps an undergraduate course. for about half participants, and another 3 out of 10 reported even less than that. So, what are our results? What you see here are the individual results for the fit for all trials, for all participants, and it's looking at the fit of the mean. Did they match the mean? So the red line down the centers, the red line down the center of each group, the bar histogram trials, dot histogram trials, box plot trials, and strip plot trials. This line down the center indicates a perfect fit for the mean. And you can see that there is some variation. The fits there are some outliers, but in the main, the fits appear to be fairly reasonable. What surprised us was that the dot plot fit is the best of all, far superior to the histogram or dot histogram forms, or even the strip plot. It's nominally better than the strip plot. The clusters are very, very tight for the box plot. Now, at first, this was slightly distressing for us because, of course, the box plot is the most abstract form, and we really wanted to see the detailed forms do well. That's our bias, but clearly the box plot is superior in fitting the mean. But then we thought, maybe we should have expected this. The center line in a box plot, of course, shows the median, and in essentially normally distributed samples like these, the median and the mean are very, very close. So there was actually an indicator of what amounts to the mean, or something very close to the mean, right on the screen with the box plot. So perhaps that's the reason the box plot was a better fit. But how did they do with the box plot in spread? How did they do with matching the spread for the box plot? Yeah, they did pretty well there too. It turns out that with bar histograms and dot histograms, there's quite a bit of spread. The box plot, again, shows less spread shows less variation from a perfect fit than do the other graphic forms. But what's more interesting is both the bar histogram and dot histogram, there's a tendency to make the bell curve too wide, to overfit, to widen it out to include everything. We call this the umbrella effect. It's as if the respondents were trying to spread an umbrella to protect the data from the rain that was coming from above, that everything should be covered rather than tightly fit. In the box plot, it's almost that they have a reverse umbrella effect. And remember, the box plots we used only had the box and whiskers, and so they didn't include outliers, which would tend to encourage a novice user. If the goal was to merely cover what's on the screen, they would tend to make the spread too narrow. And that is what we see. Strip plots had a good deal of variation, but it is an unbiased variation. There are about as many above as below. So in the end, what we found was that abstraction seemed to make fitting a little bit easier. But more critically, we do find, in answer to our central question, do people have visual intuitions for fitting a curve onto a real life data set? It does seem that they have intuitions around that, but they're biased intuitions. And so perhaps that is something that with further research we might be able to design around. It's still a hook that we might be able to use in creating tools for users. Thank you, and I hope to see you at the conference.